Okay, for this problem, they want us to use completing the square to solve these quadratics. So let's just start. So for A, I have w squared plus 28w. And then I'm going to subtract 52, right? Minus equals negative 52, because I need my constant on my right. Okay, so now I take half of the middle term, which is 14, right? Half of the coefficient of the middle term, which is 14, and I square it, right? And if I square 14, right, I get 196. And we're going to add that to both sides of the equation. And the reason why we're allowed to add 196 to both sides of the equation is the addition property of equality. We can add the same value to both sides of an equation. So now the left-hand side factors to w plus, again, half that middle term, 14 squared, equals negative 52 plus 196 is 144. So now I take the square root of both sides, so the w plus 14 is no longer squared, and I get equals plus or minus 12, right? The square root of 144 is positive and negative 12. So we get w plus 14 equals positive 12, and w plus 14 equals negative 12. That's what the plus or minus means. So now I subtract 14 from this one, right, and I get w equals negative 2. And here I subtract 14, and I get negative 26. So the solutions, or the roots, or the zeros, are negative 26 and negative 2. Okay, let's do B. I need to make some space. So for B, we have x squared plus 5x, again, equals negative 4. We need the constant on the right. So then we take half the middle term, which is 5 halves, and we square it, and we get 25 fourths. We always want to leave it in fractional form. So I'm going to add 25 fourths to both sides of this equation. So the left-hand side factors to x plus half the middle term, right? 5 halves squared. And then this is negative 16 fourths plus 25 fourths. That's negative 16 plus 25 is 9 fourths, right? So now we take the square root of both sides, and I get x plus 5 halves equals plus or minus the square root of 9 over the square root of 4. So plus or minus 3 halves. So this is really x plus 5 halves equals positive 3 halves, and x plus 5 halves equals negative 3 halves. So now I'm going to subtract 5 halves from both sides of this equation, right? And I get 3 minus 5 is negative 2 halves. Negative 2 halves is negative 1. This one I'm going to subtract 5 halves from both sides, and I get negative 8 halves, which is negative 4. So the solution set, negative 4, negative 1 for B. Okay, for C, let's make some space. C, we have k squared minus 16k equals 17, right? So half the middle term is negative 8, right? Negative 16. Half of that is negative 8. Squared is 64. So I'm going to add 64 to both sides, right, of the equation. And then this one factors, this side factors to k minus 8, again, half the middle term, squared. And then 17 plus 64 is 81. So now I take the square root of both sides, so I get k minus 8 equals a positive or negative 9. The square root of 81 is plus or minus 9. So I have k minus 8 equals positive 9, and k minus 8 equals negative 9. So k equals, I'll add 8 to both sides, 17, and add 8 and negative 1. So I get negative 1 and positive 17 is the answer for C. And D. Let's take a look at D. Let's clear this. So D, I have z squared minus 1000 z equals, I'm going to put this over on the right, equals negative 60,775. Okay, crazy numbers. So I'm going to take half the middle term, right? So half of negative 1,000 is negative 500, right? Negative 500. And I'm going to square that. So that gives me 250,000. I'm going to add 250,000 to both sides. So this factors to z minus half the middle term, which is 500, squared. Now, 250,000 minus 60,775 is 189,225, right? And now we take the square root of both sides, so I get z minus 500 equals plus or minus the square root of 189,225 is 435. Clearly, I would not expect you to have this memorized. So now we have z minus 500 equals positive 435, and z minus 500 equals negative 435. That's what the plus or minus is for. So I'll add 500 to both sides, right? And I get 935. And here I add 500, and I get 500 minus 435 is 65. So the solution set is 65 and 935. That's where it crosses the x-axis.